Okay, thank you. So good afternoon, everyone. This is Mark Roberts from Red Hat, and I'm going to present the serverless session for you this afternoon. So why do we need serverless? What will this provide for us? Well, there's a number of advantages to using serverless, and one of the most is really about hiding the infrastructure and the deployment details. And that gives us that great cloud agility to run our applications everywhere on OpenShift platforms, wherever they may be, on whatever cloud platform, on bare metal, we can run them anywhere, wherever we have our Kubernetes environment. And that allows us to focus just on our business results and focus on the things that are important rather than thinking up front and planning ahead for things like demand that we might expect and for that scalability. It also allows us to run things in a more event-driven manner as well. So we can connect serverless components to various elements of middleware and infrastructure technology and take feeds of information. We might not know where they're always coming from. We might not always know the format. We might not always know where they're going, but we can build up together rich applications that have very loosely coupled interfaces between the various different elements of them. And we can get the scalability that we need. And many of you might be from retail organizations. You know, it's early December now. We're seeing a huge increase in online shopping taking place, particularly this year. So a lot of retail organizations will be making sure that they capture all of those deals, that they have a consistent and a reliable and a performant offering to put in front of their customers. Now, serverless for me is really a lot about trying to make sure that we ensure that we are making efficient use of our Kubernetes resource. The last thing we want to happen as an organization transitions across to running their workload in a containerized manner is to flood that container platform with workload that's sitting there running at 1 or 2% of utilization, occupying CPU and memory and increasing the amount of infrastructure we need to provide a platform. So we want to spin down and make as little use of our infrastructure as possible when our applications are not being used. And many of you have probably seen this operation already. If you've got a car that turns itself off when you pull up at traffic lights and knock it into neutral, or maybe if you just pull up in an automatic and stop, turn the engine off and wait, and you're not using any fuel at all at that point. You might be lucky enough to have a really high performance car with, an 8-cylinder, 500 horsepower machine. But in actual fact, when those really powerful cars are puttering along through the high street at 30 miles an hour, they turn off banks of cylinders and they switch off infrastructure that's not required for the amount of performance we're being asked to deliver at that point in time. So some of the market trends around serverless are that there's an extremely dramatic rate of growth in adoption of serverless technology. Lots of organizations are looking at it and expecting to use it within the next 12 to 18 months. And 60% of those practitioners that have reported reduction in operating costs. And the scaling to meet the demands of the organization automatically does two things. One, it makes our infrastructure scale in the manner that we need it to. And two, we're not having to put a great deal of human effort and planning into making those things happen. So OpenShift Serverless, like everything else that you've seen this afternoon, the Quarkus and the Open Data Hub, is delivered to an OpenShift platform as an operator. And you install the operator really quickly and easily. The operator entity itself is something that is easy to maintain over time, allows you to keep things current, keep your entire platform up to date and fresh, keep the operators that run on it up to date and fresh as well to take advantage of everything that's happening. Now you can use whatever programming language or runtimes you like when you run on the serverless infrastructure. It will take care of all of that for you. And there's a rich ecosystem there of event sources that you can use and connect to as well to feed into your serverless applications. Now, this is all based on an open source project, as you would expect from Red Hat, the open source Knative project. And that's the upstream community-based project that we are participating with, that we are working with to deliver this as the supported OpenShift serverless entity running on OpenShift. Now you can see two key elements there. We have serverless serving and serverless eventing. Let's focus on those. So serverless serving is really an event-driven model that allows us to scale our applications up and down as appropriate for the workload. And I'm going to show you that hopefully in a few minutes' time, a very simple application. It allows us to scale our applications to zero, the equivalent of your car switching itself off at the traffic lights and using no resource while it's there. And that's fantastic from the point of view of scaling up and down. And you can set limits on that. You can have control over it so that you don't have runaway applications that will consume more resources than you would ideally like them to do. On the eventing side, this allows us to connect together sequences of applications that build up a larger microservice-based application. It will allow us to connect together to various different middleware and infrastructure technologies and integration technologies from Red Hat and from wider that will allow us to create applications that will hand off data through a chain of events to create the applications that we need very quickly and easily. And it will reduce the complexity within the applications that you produce. So on the left here, we have a basic Kubernetes set of YAML. And let's face it, not many people particularly enjoy diving into YAML here. But on the left, we've got a deployment descriptor there. We've got a horizontal pod autoscaler. Those are fantastic. Those will do a great job for us. We can set the limits there, as you can see, with the number of replicas we want in that autoscaler. But alternatively, we can get exactly the same thing from using serverless with much YAML configuration to create. So yes, you still get that opportunity to store your infrastructure definition and the way your application will behave in a source code format, if you wish. And then you can still operate your GitOps processes to deploy that into your various different environments. But it's much reduced in the scale and the complexity of what you need to deliver that. Now, there are a number of ways that you can get your applications to behave in sort of canary rollouts where you gradually migrate traffic from one version of an application entity to another. You can do it with the basic service object on OpenShift. You can do it with service mesh if you wish. But you can also do it as revision splitting on serverless. So this is shown in the center there is the topology view on OpenShift. And you can see quite clearly that we've got 50% of our workload there is split between those two different versions that we have of that particular application. The arrow in the top right corner there on the box with the blue outline is the route into that application. And by hitting that route, the serverless capability on the platform is going to distribute that traffic 50-50 between those different versions. Now, the different colors that you see there are the different states of the pods that are running to deliver that capability. And I'll show you a little bit more of that in a second when we get to the end. So let's have a think about a few examples of where this could be used. And let's have a think about scheduling a fulfillment of cron jobs. Now, on the left here, we've got some scenarios of where we might need to run an application hourly, daily, weekly, monthly. And depending on your industry, you will probably have those things to happen where you get a spike in demand, where you might need to generate invoice data, you might need to generate account statements for people, on a periodic time. And that's going to generate a big spike in demand. And in this instance here, it's sending out information, it's retrieving data from a source, generating invoices, creating PDFs, emails, and then sending those out and storing them. Now, that's a fairly meaty application to provide that functionality. I don't want that running all the time. So that's something that we could deliver from a serverless manner. Another example here from a medical world. I did a little bit of work years ago transferring x-rays around the world, and every few years that the resolution of x-rays grows so much that the amount of storage space that they take up, each x-ray takes up, doubles in size every 2 or 3 years as new machines become available. That's great from the analysis point of view, not so good if you're responsible for storing all of that data. So here you can see we have a new x-ray come in. That will create a Kafka stream where it's hitting a particular topic there, where it's storing it. It's passing that on to the event image analysis process, where that's looking for particular anomalies to give an indication of a particular condition. And then that's saving that data back for it to be reviewed by a clinician later on. And step 7 is saving that data into another area for research, but the data has been anonymized. So we've taken out any personal identifiable information in that final bucket at the bottom. Now, again, that's a huge volume of work to be done to process that data. An ideal example of where we are using loosely coupled technologies, but also where we're scaling things up to cope with that particular demand of doing that data analysis. And the thing that Ian talked about earlier on in the first presentation, machine learning, is an obvious example where you do get high spikes in processing requirement, which are ideal scenarios where a serverless technology could be used. So, by way of a quick summary of OpenShift Serverless, we can scale our applications to 0 and scale up to meet the demands that are placed upon our applications. We've got this powerful eventing model where we can use multiple event sources feeding into our applications, pulling data from wherever. You've just got to think about everything that's going on right now with the NHS trying to identify people that should get the COVID vaccine first, all the research projects that have been done. Seen some huge projects have appeared out of nowhere, pulling data from all sorts of different locations and feeding that in to make decisions, and then to send out the notifications to who's going to get those vaccines first. All of that type of technology is ideally suited for these loosely coupled applications that we can put together in this manner. And as you can see on the right hand side there, we get wonderful annotation showing us exactly what's happening in our applications. And that's what I'm going to try and show to you now. So I should be sharing my entire screen. And
5 minutes, Mark.
Sorry?
5 minutes, Mark.
5 minutes. Thank you, Graham. So 5 minutes should be fine to take you through what I want to show you right now. And you can see that we have an application topology shown on the left-hand side of the screen there. And we have a clear circle around the outside. And that means I've currently got no pods running in this because I've been talking, my application hasn't been exercised. And I've got a few commands down here that I'm going to paste into this window just so that I stay on time. And we can have a look at the revision list. And we can see that 100% of the traffic is going to that particular application. So the application ending QKR12 is getting 100% of the traffic. But that's not what I want because I have 2 revisions. I have version 1 and I have version 2 of my application. And I'm going to change that distribution so that I get a 50-50 split between version 1 and version 2 of my applications. And then to test that out, I'm going to curl my application and send it some workload. But again, at the moment, you can see on the left-hand side, actually nothing is running right now. I don't actually have a live pod. So I'm going to curl my application and I'm going to grep it for color and see what color comes back. And you can see the blue ring appearing there in version 2, starting to spin up. And we've got a response, green, from version 2. If I hit that again, now version 1 is spinning up. So I've got a nice 50-50 split and I get blue there from version 1. Now let's hit them again. I get blue, I get green, blue, green, blue, blue, green, green, and so on. So I'm getting a really nice 50-50 split there between my applications, which is fantastic. And I can adjust that and I can actually do that graphically. So over here, I have my set traffic distribution and I can use that to change the distribution if I wanted to. Let's make it 70 and obviously 30 to split that distribution in there. And now the graphic display will show that, but I'm not going to exercise it to prove that point right now. What I'm going to do is switch us back to just having one of them running. And I'm just going to change it so that we have all of the traffic going to the latest version. And I think I pasted that rather badly. Try again. There we go. So I've now got all of the traffic going to the latest version that exists of my application. Now I want to see what happens if I hit this application with a huge amount of workload and ask it to do a lot. Now, first off, let's just describe the application and see how it's running. And I'm grepping for the word auto scaling and it's set to 5. So that means that my application is going to scale to a maximum of 5 pods to support the workload. I want a current concurrency of 5 running in this. So I'm now going to use an application called Siege to fire some workload to it. Before I do that, I want to see how many pods I have running. Oops. So you get pods, and it tells me that it's terminating. So it's just mopping up now, getting rid of the pods that we had previously when we had those blue and green responses. It's terminating those and spinning them down. Shortly it would report that it had no workload whatsoever. So I'm now going to use an application called Siege, and that is going to, let me copy this. I'm going to fire a large number of workload at it. So I'm going to ask it for 20 concurrent connections, and it's going to fire workload at it for 15 seconds. So here we go. So immediately that starts to spin up. And if I click on here, what you'll see is that we have lots of pods being created. So I have one that's running, as you can see, with a dark blue ring. I now have 2 that are running. One's not ready, 3 pending, and it's spinning up that workload. And you can see that we have processed 1,802 transactions. And if we have a look at the number of pods that we have at the top now, then I've got, what, 1, 2, 3 that are running and a few that are still just showing as pending. So it's spinning up additional workload to cope with that demand of what we are looking for. And gradually over time now, if we just sit there and watch this decay down, we would see those spinning down and gradually reducing back again. So it's a bit like my high performance car puddling along at 30 miles an hour, going to a 60, and I floor the throttle, and it provides all of the cylinders available to me. And then when I go into the next town, slow down to 30, it turns off a bank of cylinders. So it's exactly the same way that it's operating. So it's fantastic in that I'm not having to do a great deal of extra planning for this. You can see the black ring now, well, it's starting to scale things down. It's terminating them, so they are on the way off. And you can see after that spike of demand, it's now scaling things down. So it's a fantastic facility. All I've done is set the parameters that I want it to operate within, and it's done everything else for me. And that's serverless for you. So thank you. Let me just move us on to our last slide to say thank you. I'll hand over to Graham.
Brilliant. Thank you very much, Mark. So that was serverless using Knative in OpenShift. Great. So thank you very much for all of the speakers. So we've got about 7 minutes left of the hour. Just open it up for, open the microphones up, unmute yourself if you want to ask a question to any of the guys that were presenting. Or if you don't want to speak, you can stick something onto the chat and we can ask questions by chat. I haven't seen any particular questions other than a bit of back and forth between us on the chat. So yeah, any questions from anyone? So I'll open up with a one to Phil. So when is JavaScript going to be on Quarkus, Phil? You're on mute, mate, which is probably a good idea, given the profanity that's probably coming out of your trap right now.
Yeah, exactly. Yeah, as I said on the chat, I'm not going to respond to that, mate. But I don't. It's certainly not on the roadmap. I've not seen Java, unless you could tell me it's on the roadmap. I've not seen JavaScript on the roadmap. Kotlin and Scala, though, are both languages that are in preview.
Well, I guess anything JVM based is kind of fair game on there, isn't it?
Yeah, it's fair game. Yeah, it's just a matter of the community doing it. It's the thing about Quarkus now is it's gone beyond what was a research project inside the Red Hat that we did up in the community, and it's just gathered its own. It's like a big snowball now. It's got loads of people involved with it. So yeah, everything's fair game.
What would be interesting to see is doing kind of migration projects. So kind of the value of migrating from a Java app to Quarkus. Is there any value of doing that, and kind of what the take up of customers trying to do that is?
So there's a two-pronged answer to that, really. So we see ourselves as a micro-profile platform more than a Spring application platform. but there are a lot of people that use Spring and Spring Boot in particular in sort of microservices world. I'd say in either case, if you're microprofile or Spring Boot, moving those across to Quarkus, you're going to see massive memory savings, if nothing else. If serverless and startup times you don't care about so much, you're still going to see big savings. If you look at things like Azure functions, and if people are using Lambda and that type of stuff, then again, you're going to see monetary savings by moving to Quarkus. And so what we've done as well is we provide a migration toolkit. And so the biggest thing that you need to do when moving, say, Spring Boot to Quarkus is you need to change your dependencies to be the Quarkus extensions. So the migration tooling has, it's around about 30 rules now that will go through your Spring Boot app, look at, or Spring app, I should say, rather than Spring Boot app, will go through your Spring app and then tell you the dependency changes that you need to make. It'll also make recommendations whereby it can replace a Spring extension with a Quarkus microprofile extension, if that's something you want to do as well. So yeah, so we have tooling that helps that process as well. We have services people that have lots of experience of migrating people from monolithic to microservices, if that's where people are, or indeed from one microservices framework to another microservices framework.
Good answer. Any more questions from anybody else? I see there's nothing on the chat there, so I'll ask another quick Quarkus question then, Phil. Mandrill. Mandrill. Yeah, well, I'm just interested in Quarkus, right? Not that I'm not interested in Mark or Ian's stuff, but
I try to enjoy my beer. Yeah, I need to get another one.
Well, Mandrill. So, are we GA with kind of the native? I'm talking Red Hat here. So Red Hat product. I know in the community we've got GraalVM. So tell me about what's Mandrill, right?
Yeah, so Mandrill is Red Hat. So Mandrill is Red Hat's downstream version of GraalVM. So if you think of GraalVM as a community project, which it is, and you think of Quarkus as a community project, which it is, what we then have as a downstream Red Hat enterprise product is Red Hat build of Quarkus, but then we also need a downstream build of GraalVM as well. So we can support it, patch it, secure it, and do all the magic that Red Hat does to the community source. So Mandrill is Red Hat's downstream version of GraalVM. It's not the whole of GraalVM, by the way, as well, because GraalVM is a polyglot VM, basically. So it's only the Java side that we take into Mandrill, which is important to understand. It's in, I believe it's still in tech preview. I don't believe it's GA'd yet. So to the best of my knowledge, we only support from a Red Hat build of Quarkus, OpenJDK at present, and it's in preview mode for Mandrill.
Cool. We've got a question from Alan. He's asking, so you're talking about microprofile. Does that mean Quarkus is based on J2EE or JEE?
No, definitely not. It's always a weird one. So microprofile has nothing to do with JEE. JEE is a standard. Microprofile is a community. It is not a standard. And that community is sort of Red Hat, IBM, Oracle, and some others. In fact, probably the same suspects you'd see in JEE. What it means is, as a platform, it can move a lot quicker than the standard can. So you'll find in microprofile, we release new microprofile versions every 3 months, I think it is. So there's been it's around about 12 releases since microprofile came about. Microprofile had to start somewhere, and so in starting somewhere, it took a lot of the APIs that were appropriate from JEE. So things like JAX-RS as a prime example of that. JPA, for example, for object relational mapping on the database side and that stuff. But what microprofile then does is think about, well, how do I do things like readiness checks, health checks? How do I do the status of my application? How do I expose its metrics? All of the cloud native capability that you would expect to see in an application comes out of that as well. So its heritage, I would say, because of getting a starter for 10 was JEE, or Jakarta EE as it now is. But now it's its own thing. So it's not part of JEE.
Perfect. Thank you, Phil.
No worries.
Right, we're at the top of the hour. So again, thank you to Phil, Mark, and Uth for the sessions they presented. Thank you to Naz, who's been backstage, kind of running some of the stream stuff. So thank you very much for that. We're happy to stay and hang around for a little bit longer and answer some questions, because I've just seen another question pop up. I know Phil's got to go and get his hair cut, but apart from that, thanks everyone.
I can take that question if those that want to go.
Great. So Dave Meredith, so that's the question. So what core parts of Spring are trickiest to migrate to Quarkus? Will I see lots of required changes?
So you will see some potential. The biggest gotcha is when you go to native, as opposed to, so if you take a Spring application and move it to Quarkus and run it on Hotspot, there's less gotchas. So the first question, and I can't tell you this, I'd have to go to Quarkus.io to check, but we don't support all of Spring. We only support so we have a set of extensions. If you could pull up that website, you could probably list those extensions for me while I'm chatting. So there's a list of extensions that we'll support, and within there are then some gotchas if you go to native code, and that gotcha in particular is around Java reflection. So what happens is, through that native code compilation, is we actually go through the code, we run the application, we determine all of the Java classes that are required at runtime. And of course, we do that by looking at the source code effectively. So if there's Java reflection in the application, we don't see those dependencies within the classes. So the gotcha is, you might find at native code, when you call the class, you get a class not found exception because it's been removed from the execution. And so you can get over that. So there are tags. So we have tags that you can use, or annotations, I should say, that we can use to actually say that this class is for reflection, and therefore the compiler will build it in regardless of seeing it in a call chain or something. So that's the biggest gotcha that you're going to find. And then it's only the Spring extensions that we support, but they should be fully supported. I think there's a couple of gotchas in there again somewhere, but it's documented on the Quarkus.io website. Did you find them, or?
Yeah, I'm just looking at them now.
So I've got it. It's in front of me if I can find the browser.
Okay.
I've got too many screens. That was my problem with muting before. Yeah, so we've got Spring Cache API, Spring Cloud Config Client, Spring DI API, Spring Data JPA API, Spring Scheduled, Spring Security API, Spring Web API, and Spring Boot Properties. So those are what are part of it. And to be clear, they are in preview at the moment as well. They're not GA.
And that's growing, I'm guessing.
It's growing all the time. Yeah, it's growing. It's like, if you take a look at the extensions that are there from, how long's Quarkus been around? It's been GA'd since about, it must be about getting on for 12 months. It's been GA-ish in upstream, in community. And the amount of extensions that have come out of the community in that time is just phenomenal.
Yeah, you can see the community. Yeah, the community, just the activity there is phenomenal.
Yeah.
Yeah, it's one of those where actually just the value of the tech is just huge. So lots of projects, lots of things that are getting added to it. Yeah.
Yeah, it just makes sense, right? If people are doing Java and you need to save memory and get dense deployment, which is what you need in container land to make it cost effective, then it just makes what it does is just makes sense.
Okay, so there's no more questions on the chat. So last chance for anyone to ask a question before we wrap it up. Cool, just lots of great, lots to take away. So we'll look out for more of these sessions. We're planning on doing some lightning talk, these types of sessions, once a quarter. We'll also do we'll bring in another two, which are just single subject, long, for 45 minutes to an hour. But yeah, keep an eye out. We'll be doing more of these. we'll be putting this video we're on Twitch. So this is streaming at the same time on our Twitch channel. And you'll be able to pick it up on YouTube as well as a video. So we'll post all that information so you can pick it up from there. But keep an eye out on those channels because we'll be doing other stuff. There should be things going on from us as a community of kind of UKI-Developers. We'll be doing more. So brilliant. Thank you for everyone for attending. Thanks for the contributions. So we'll catch you all soon. Bye.
So